time. So I'm kicking off with the first session in Zoom room 2 about chasing a bug, or 2 bugs actually, that I accidentally discovered. Well, you know, you get a call from someone like, can you check this? And then in the end you spend like almost a year changing something. So what happens? Well, let's first, for those who don't know me, I see quite a few usual suspects in the participant list. So hi to you all, but also like yesterday I did a pre-conference class and there were a lot of people that were at SharkFest for the first time, and I can imagine that there's a lot of people here at my session also joining for the first time. So welcome. I'm glad you're able to join, maybe because of the virtual format. So who am I? I call myself a relational therapist for computer systems because I analyze traffic between systems to solve problems, just like a relational therapist looks at communication between people. I look at communication between systems. I started using Wireshark or Ethereal, I think in 1999, and started developing for it a few years later and became one of the core team members in 2007. And in 2010, I started my own company to focus on troubleshooting and training, and so one marketing slide for that. But let's continue with the story. And as any good story, it starts with a prologue. Like last year in May, I got an email, or the project engineer sent an email to the project manager, like we're building a new cloud environment, and he saw retransmissions and duplicate packets. And he was asking, like, can the network team investigate? So he came to me and I asked, like, I see some duplicate traffic. Not all traffic is duplicate. Do you have a network diagram? And of course, yes, I'll make one diagram after Project X. Well, that took like 2 months. And so I asked, like, were you able to make a network drawing? And then the project engineer said, okay, here's a drawing, and shall we have a look at the problem together next week when I'm there? Because I'm only working for that company like 1 day a week, so things are progress a little slowly. So yeah, let's see what the first PCAP was that I received from them. If all goes well, you can see my Wireshark screen. And yeah, you can see a lot of out of orders, retransmissions, a lot of black lines, and a lot of havoc. But the fact, is there really a problem? That's the question. If you see things like this, I always think like, this can't be true. So I kind of check. So if I look at this retransmission, look at the IP ID, let's see if it was really a retransmission or maybe a duplicate. And in fact, if I filter on the IP ID, I can see that it's actually a duplicate and not a retransmission. Because if it was a retransmission, it would be a new IP datagram and it would have a new IP ID number. But since these are the same IP IDs, I think it's a duplicate. So if you go to the command line and do edit cap -D to remove the duplicates in a new file X, open this. And go back to Wireshark. Now everything is clean. So this was basically like an error in how the capture was made, and the capture was made on an NSX host or an NSX engine, and apparently some setting was causing it to behave badly, or maybe it was a bug in NSX. So after looking at the PCAP, I said, well, dear project manager, we looked at the traffic and it seems to be an artifact of the way NSX is capturing the packets. So not a production issue, but we might want to need to open a case. And then a week later, yeah, we changed something and the duplicates are gone. Thanks for your help. Well, so not much there. There was like, okay, easy case, remove the duplicates and nothing really important going on. So that was the prologue. Then, like 3 months later, I got another email like, hey, I still see retransmissions. Can you have a look? Because yeah, we're worried that when we go live, this might be a problem. And just a little later, hey, we see problems in the same retransmissions in the production environment too, not only in the new cloud environment that they're building, but also in production. So we started to look at them, and let's see, open up next trace file. And it has been anonymized by Trace Wrangler, so you don't see anything if it all is well. And I was scrolling a little bit, and I was looking, okay, there's retransmissions. Like there's a black line here, over here, retransmissions. So looking at this retransmission, so it doesn't come after duplicate X, so it's not a fast retransmission. But it comes like, if I look at the sequence number, let me filter on the sequence number, apply filter selected. There's only 40 milliseconds of delay between them. Like what do we know about retransmissions? It's either a retransmission timeout, in which case there will be like in the old days it was 3 seconds, and now it's like 300 milliseconds, and it can change over time, but it's usually more than 40 milliseconds. So why does it send a retransmission after 40 milliseconds? Well, it could be a fast retransmission, but as I already checked, between this packet and this packet, there are no duplicate X. So the server doesn't know that there's packets missing. So that's strange. So this is like, okay, something weird's going on, and we need to investigate. And this is actually traced from the client side, and you can see in the ACK on this retransmission. If you look closely, you see that there's a left edge and a right edge. And as you can see, these numbers are below the acknowledgement value. So this means this is a duplicate SAC, duplicate selective acknowledgements, which means this proves that the client has already received this frame. It didn't acknowledge it yet, but before it was able to acknowledge it, a retransmission came in, and then it was able to acknowledge it with a duplicate SAC, a DSAC, to say, okay, I received this already. Why did you send me this again? So something is going on. Like, why is the server retransmitting like so quickly? And the traffic on the server side basically looks the same. So let's skip that for now and go back to the presentation window. So, dear project engineer, I analyzed the files, and there's something strange going on. The retransmission seemed to have very low RTO, not waiting on delayed ACK packets. I Googled and found info on TLP, the tail link protocol, I can't remember, which seemed to be an optimization. It might be interesting to open a case with Microsoft to investigate any further. And that's the start of chapter 2, in which we opened the case with Microsoft. At least the Windows team in the company did that. And so in short, we saw some low RTO values, could be related to TLP, set up links, a little more description, of course, but it's too much to put in a slide. And with the question, what triggers this behavior, and is this works as designed? And then, of course, an answer came back. Hello, customer. For the understanding of how the TCP transmission works, that's actually a literal sentence from the email. And then a whole explanation on how retransmissions work with a backup mechanism, etc. And like something like, oh, okay, I already know that. You don't need to tell me that. So then the little dance started to get the proper attention within Microsoft, and that took like more than 2 months, or a little less than 2 months in this time frame. I provided PCAPs. They asked for net shell traces. I was trying to explain the behavior and trying to discuss the actual packets, but they were going through in links with all kinds of default knowledge base articles, of course. So I escalated the case, got 2 engineer changes, and finally the third engineer said, okay, hello customer, I had an update from the product group, and that's the internal networking product group within Microsoft. They have suggested to use the internet TCP template and check if the issue persists. Please check and let me know. And that's like TCP and templates, internet template. What is that? I never heard of that. I'm not sure whether you did, but for me that was new. So I started Googling, and apparently there are several templates that a Microsoft server and also a workstation can use. And there's basically 4. You have data center, internet, data center custom, and internet custom. And I think there's a 5th one, but I can't remember. And both the different templates use different settings for a lot of things. So you can see settings here for the minimum RTO, the initial congestion window size, the congestion provider, like the algorithm, like if there's a restart on the congestion window, delayed UC timeouts, etc. Like a whole lot of sessions, initial RTO in milliseconds. So you can see that it's using different settings for the internet and different settings for data center. But how does it make a distinction between those two? And I found an article on Microsoft saying, okay, the RTT, the round trip time of the connection setup, is actually determining whether it should choose the data center or the internet template. And if you set it to customized, it will choose the custom version of it. But standard, it will use the data center or the internet version. Okay, fair enough. So that's something I learned, that you can tune that, and that you can look at what profile or template has been chosen. So again, I was being asked to create net shell traces, and in my production environment, there was just too much traffic, and it turns out that the net shell filtering doesn't work properly. So if you try to filter on IP addresses, you're out of luck. It doesn't do that. It just gives you the whole net shell trace for all packets. At least I didn't find a way to filter properly. And as the problem was not occurring very often, and I couldn't really see quickly when it was occurring, I always had to do that afterwards. I had like I don't know, 10 iterations of capturing everything, looking through the traces, trying to find the problem, not being able to. And so I had to do something else. Also, there was another case handover to yet another engineer. And that started chapter 3. Let's see, how am I doing in time? I'm really getting quickly through this, but at least more questions for the Q&A.
Sake, if you want.
Yeah.
Could you reiterate, there was a question on the Q&A already, could you reiterate how the traces were captured, if they were wire or on the endpoint stack, etc.?
Okay, yeah. The traces were made on the endpoints. So Microsoft asked for net shell traces because they have tools that can analyze those, and there's more information in them. So they asked for net shell traces, and those need to be made on the endpoint itself. And also because I love Wireshark and not like traffic analyzer, packet analyzer. What was no, it's called differently, but the Microsoft tool, I don't like it, or I'm not used to it, so I can't really use it. So I made PCAPs as well, and but they were all made on the endpoints. Yeah. So I was looking for a way to reproduce this issue without falling back to production traffic. So I asked for 2 Windows VMs. I got 2 Windows VMs just for me, so no other traffic. And yeah, so it was reproduction time. But how do you reproduce such an issue? So I started thinking, okay, it needs to be, there needs to be traffic. It doesn't happen all the time. I need something that I can install easily. So let's try FTP. Let's see if I can reproduce the issue with FTP. So I created a script that like looped through an FTP command, and in the FTP command, I used a text file with all the commands that needed to be executed. So I opened up a connection to the server, logged in with my username and password. They're very, very secret. And then I start a PowerShell command to show the status of the sessions to this server. So in my rolling output, I will see whether the data center or the internet profile has been chosen. So I have a little indicator of whether my reproduction is working or not. And I'm getting the file udpjoke.png. And I do that over and over again. And then a little timeout, or a little sleep. It's a sleep routine to pause for 2 seconds and then disconnect and quit, and then do the next iteration after again 2 seconds. On the so that was on the client, and on the client and on the server, I also had a PowerShell script that logged the connection time and also the states. So I have that in one file as well, and all that output was collected, and then I saw on the client side the above list, and on the server side the below list. And what you can see is there's a difference. Like on the client side, it shows sometimes the internet profile, and on the server side, it sometimes shows the data center profile. Like, that's weird because it's based on the round trip time. So how can the client choose the internet profile unless through your handshake is like more than 10 milliseconds? And of course, the client has a different perspective than the server. So it could be that it's just around 10 milliseconds, and maybe the client has a little bit over. So let's look at the trace in a second. But if you take into account that the profiles of the templates that are used are different, if you look at the data center profile, the minimum RTO is 20 milliseconds. So depending on network conditions, the round trip time that starts off with 3000 milliseconds can get as low as 20 milliseconds. And if you look on the data center, the internet template, you can see that the delayed ACK timeout is actually put there as 50 milliseconds. While on the server profile, or the data center template, it's 10 milliseconds. On the internet template, it's 50 milliseconds, which means if the client is using the internet template, it can wait 50 milliseconds before sending a delayed ACK, and the server can already send the retransmission after 20 milliseconds. So this is something that might be causing a problem. So again, let's open up a trace file. Open part 3. And let's see first about the connection setup time. Like, it's only 700 microseconds. So let's see if there's an initial round trip time. Let's see, it's in sequence analysis. Let's see if there's in the trace a session that has prepare a filter selected. Let's see if there's anything that is more than 10 milliseconds. And there isn't. So there's no, let's do it like 2 milliseconds, not even 1 millisecond, not even 500 microseconds, no. 200 microseconds, no. Well, maybe my filter is not wrong, because I should get something here, I think. Like 1 microsecond. That's strange. Let me check. Oh, okay, yeah. Thank you for the comment. I should have changed something too. Oh. That's what you get when you do pre-conference class till 2:30 in the morning. You're a little bit tired the day after. So TCP dot analysis initial round trip time, and it should be not equals to 10 milliseconds, but of course more than 10 milliseconds, which is not there as expected. 1 millisecond, not there. 100 microseconds, okay, it's there. So 900 microseconds, so nothing more than 900 microseconds. So not close to 10 milliseconds. So the fact that the client chooses the Internet template is really strange. And because it chose the Internet profile, of course, with the data center, I keep saying profile because of Wireshark profiles, but it's called templates. So I should say templates. So if the client chooses the Internet template and the server chooses the data center template, then of course, because of the timers, things can go wrong. And what's the problem with this? Because if you look at, they're just very quick retransmissions. So what would be the problem with this? It's just a few extra packets, and should this cause any problems? Well, we haven't seen any production problems with this, but as soon as you have retransmissions, your congestion window will be lowered. So in the end, this could mean that if you, after these retransmissions, want to do like a streaming transfer of a large file or a large database transaction, it could be limited in bandwidth because of a reduced congestion window. So that's why I pushed hard and Microsoft, okay, I want to have this investigated and see what it does. And so yeah, they confirmed that this is an issue. I think it was a new issue, or this issue was actually maybe they've seen it before, because I think they reacted like, okay, this is a known issue, but it hasn't been fixed yet. But then something else was pointing in my face. Wait, there's something more. Again, go back to the trace file, and I hope I can find it easily. Like if I'm searching for bear X, oh, this is not what I want. Now I need to start searching for bear X, and so let's search for TCP.length equals 0 and TCP.time delta larger than 0.0 to 20. So there are a couple of packets, and if you look at the output from the scripts that I had, so let's see, I had the output here. Yeah, let's see. So this is the output of the PowerShell script, and if I choose all the data center ones, so I can choose the port for the data center connections, but I don't want one, I want them all. So let's cut this to awk, and then 1, 2, 3, 4, 5, 6 awk 6 still be equal to data center, and then print 1, 2, the second field. These should be the ports of all the data center connections, and I can sort them numerically and unique. So I get a list of all the ports that were associated with sessions that are using the data center profile instead of the internet profile. And if I do X arc, I get like a nice list that I can use in Wireshark to filter these packets. So now I'm gonna say TCP.stream needs to be in this list of ports, and then it doesn't work. Still, there are, well, it's not TCP stream, it's TCP port, of course. I usually do stream filters, but this time it's a port filter. So I'll go back to this filter. Here you can see that there's actually, within using the data center profile, I can see here there's a delayed ACK, or an ACK that's actually using 25 milliseconds. And if I follow this session, conversation filter for this TCP session, you can see that there's a 25 millisecond delay, which is actually too large because the data center profile had a 20 millisecond delay. So in this, so this got me worried. Like, okay, the delayed ACK timer is not corresponding to the settings actually that are in the data center profile. So I started investigating further, and if I look at the data center profile, do I still see the retransmissions? So let's scroll a little bit. And, there's one. So here you actually see, well, this is after 90 milliseconds, so that's within the 20 millisecond range. So that could be, yeah, that's not the one that I want. I want something that it's, you can see that it's actually, so let's do a find on tcp.analysis.flag, no, not flags, retransmission, and tcp.time delta is greater than 0.020. And here you have one, well, let's do a little bit higher. Let's do it higher than 25. That's not in this trace. Okay, I had that in other traces. But I had a hard time finding all the traces that I used during the case. Because if you do something like this, like a year or 6 months after actually doing the case, you forget which traces contain what. But in the end, if I look at the traces that I created, there were some retransmissions going on after, I think it was like up till 30 milliseconds. And well, the data center profile should say that after 20 milliseconds, you should see delayed ACK. And so there were also these unnecessary retransmissions whenever the server did choose the data center profile instead of the internet template. So I sent that to Microsoft as well, like, okay, there's a second issue that you need to investigate, and actually that one was a new issue to them, and they investigated it, and they confirmed that it was an issue, and that they need to work on that. So let's go back to the presentation. So yeah, two new cases, or at least one new case was confirmed, and the other one, I think it was already known, but I'm not really sure, but at least the second one was unknown. So the client occasionally picks the wrong TCP template. Instead of data center based on the round trip time, it chooses the internet one, and the delayed ACK timer can be higher than what's in the template. And that's what they said is because of clock tick timers that they actually, sometimes they don't get triggered fast enough. And that's something they're working on to fix. No bug numbers. Unfortunately, they don't tell you which numbers. I can't reference to them, nor do they provide a time to fix. It's just, okay, contact your account manager once in a while to see whether there's actually something already been fixed. I contacted the account manager last weekend, and I got a reply this week, but there was a reference to an update on Windows 10, but it actually I didn't see any reference to this behavior. Plus, I'm not sure what it does to the server versions of Windows. So I'm still looking for an answer whether this will be fixed yeah, in a short time frame. So is there a workaround for this bug? Yes, of course. If you encounter this behavior, what you can do is you can change the setting. Oh, I thought it was I could highlight something, but I can't. So you can set in the data center custom, you can set a minimum RTO of 100 milliseconds. So that's way larger than the 20 milliseconds or the 50 milliseconds in the internet profile. And then into the template, I'm saying it again. And then you can set a filter that every traffic should use the data center custom template instead of the normal data center template. And of course, you can roll that back to set the data system custom again back to 20 milliseconds and remove the filter that selects this template. When you want to check the settings, you can do get that TCP setting, all PowerShell commands, by the way, and get that transport filter to see if the filter is still in place. And of course, if you want to check the connections, you can do get net TCP connection in error action silently continue. I found that out that if you have no connections at all, then if you do a filter with a remote access and with a remote address, then you get no you get an error message, and I didn't want it. So there's a silently continue option. Yeah, so that's basically, well, wait, what? What about UDP joke.png? Well, that's actually this image, as you might have seen it before. So, a little bit short, it's like only 35 minutes and I have like, I think an hour or at least 50 minutes. So there's lots of time for questions. Let's see in the Q&A if there's, at the beginning, you mentioned something about an error on the packet capture. Okay, with some retransmission. Could you please repeat the thought process? Yes, I can. So if we go back to the first capture file, where's my Wireshark? There it is. And open up the prologue. So whenever you get a capture file with a lot of red lines, and this is actually, well, there are different sessions, so let's just filter on one session. Apply filter for the TCP stream 0. If you see a lot of these red lines, and actually this is only one side of the traffic, because if you make a trace within NSX, you only get one side of the traffic, unfortunately. So you have to deduct everything from one side. But you normally see that there's no, there's actually no, yeah, what do you normally see? Yeah, you see a lot of red lines, but it doesn't match the normal pattern of retransmission. So you need to start looking, okay, are they real retransmissions, or is this something of an artifact of the capturing? Like, I know that when you capture on a span port, if you capture a VLAN and you don't select a direction of your traffic, you will see every packet twice, because if you capture on VLAN 10, every packet will enter the VLAN and every packet will, and the same packet will leave the VLAN, and both will be captured. So whenever you capture on a VLAN, you need to select either receive or transmit. So based on that knowledge that I've seen before, that in a lot of cases the capture was not made right, I got a little triggered here as well. Like, okay, every packet seems to be retransmitted because there's so many of them within the same session. This can't be right. So then the question is, how do you check whether something is a retransmission or maybe a duplicate packet? Well, every packet that gets sent through an IP stack will become a datagram, an IP datagram, and IP will mark every packet with a different identification field. So if you look at the identification fields. Let's create a column for it by dragging it over here. Thanks, Roland, for building that. You can see like this packet has 21, this packet has 22, and again 21, 22, then it's 23, 23, 24, 25, 24, 25, 26, 26, 27, 28, 27, 28. So every packet you see has another packet with the same identification field. And whenever there's a retransmission, it's been done by TCP, and TCP hands over a new segment of data to IP. But for IP, that is just a new datagram. So it will mark it with a different IP identification field. So in this case, when you can see that the identification fields are the same, you know that it's not IP or not TCP retransmitting this. It's actually something in the network that makes it happen that the same packet is seen twice. And I don't know, I don't remember what they did in the layer 2 infrastructure, but I think there was within ACI there were some ports not correctly configured, and that was probably the reason why some packets were, or these packets were bouncing back to the originator or something like that. I can't remember, but at least I know that after a week they did find some settings that it changed, and then this behavior of duplicate packets was gone.
So this will also answer the question what leads, right?
This will answer which question?
There is a follow-up question, I think. What leads to duplicate captures?
Yeah, you mean with duplicate? If it means what leads to duplicate packets in a capture, then yeah, this is an artifact of NSX with the configuration that was used. So there was a fault in the configuration that led to this, but I didn't investigate that part because for me, they're duplicates, they're gone, and now because we also checked on the ends. That's basically, yeah, that was what's happening. We checked on the endpoints, and on the endpoints, we didn't see the duplicates. So the duplicates were only seen in the capture process, not on the network itself. So that's an important distinction to make. Like if you see this on the network itself, it's something that you need to investigate and of course need to solve. But if you only see it in your capturing process, then it's an artifact of the capturing process. It's still interesting, but it doesn't create problems in the production traffic.
There was a question in the middle in the session if the traces you have shown can be made available as material.
I didn't check with my customer whether I was able to do that, so I can't tell yet.
Okay.
They are anonymized, but still they're customer traces, so I'm a little bit reluctant on giving them out. Showing them is different than having people look at them more carefully. So I think I won't be able to share them. Yeah. At the beginning of the first capture, yeah. So I think that was live. The question from Patrick has been answered. So let me click on answer live. Okay, that's gone. Other than retransmissions, what was the real world issue they were facing? Actually, there wasn't a real world issue. They were seeing these duplicates, or they thought retransmissions and duplicates. That was solved. And then later on they saw retransmissions on the server by looking at something else, I guess, and seeing retransmissions like, hey, there's something going wrong. And since we looked at the retransmission before, it came to me and like, hey, can you have another look? Because we see retransmissions. And so there wasn't a real life issue, but having these retransmissions, as I said earlier, it has an influence on your congestion window. And since this is seen over the whole network with all the Microsoft servers, I am a little bit worried that it might have an influence on production performance in the end. So I try to I tried to get like tests with the workarounds, but COVID got in the way, so we weren't able to sit next to each other at a whiteboard, and people didn't really understand what was going on, and it's really hard to test. And so in the end, I paused it and said, okay, whenever we get back to the office, we can discuss it some more and see if we can find a way to test this properly. Then again, if there's no problem, we did a few tests with the change settings, and that didn't show any improvement on large file transfer. So I'm not sure whether this is a real issue in performance-wise, but whenever you're troubleshooting and you see retransmissions like this, it takes time to invalidate all the retransmissions. Like, okay, are they really retransmissions? Oh no, they're because of this bug. I can just ignore them. And so for me, like I'm a little bit autistic, I want this solved because I don't want these unnecessary retransmissions that are caused by some fault in the TCP stack. So yeah, other than retransmissions, no real world issue. Thank you for the question, Jeff. RFCs for RTO. Whenever RTO is computed, if it's less than 1 second, then the RTO should be rounded up to 1 second. What is Microsoft's take on this? Well, Microsoft's take on this is that it goes lower, as you can see from the TCP templates. What Microsoft does, it has an SRTT, and it's I forgot what the S stands for. Smooth, I think it's smoothing. But what they do is they monitor the connection, and if they see that the round trip time is really low, they start lowering the initial round trip or the initial retransmission timeout. And so yeah, they're lowering it. And the second part of your question is also, if the client is not Windows, then 50 or even 200 milliseconds delayed arc timer is expected. Will never work with data center RTO. No, that's my take on that as well. Like, okay, you can lower it because you think you're talking to only Microsoft servers, but that's actually not really social. So this also means that whenever you do a Microsoft deployment in a hybrid environment, that then you should look at the TCP templates and correct one, make a custom one for your setting, and then make a filter to use that for connecting to all the other servers. So it was for me like, okay, this whole new world of TCP templates within Microsoft was introduced to me, and I think there should be some more customization, within deployments. Yeah, good addition. Ron, I think that's already answered. Were the dupe and the retransmissions causing slowness?
Yeah,
not that I could see, but it might have caused slowness, but I wasn't able to prove that. Can you revisit TLP? Is it common? Well, actually, it was something that I really, when I was looking for these minimum retransmissions, then I found some documentation on TLP. Which I have never seen before, and actually it wasn't involved in this whole case. So I'm not sure if it's common. I'm not even sure if it was involved in the Microsoft stack either, but it was the first hint that I got that could prove this behavior that I saw that there was a retransmission so quickly. So yeah, if you look at, let me check if I have those links somewhere. I don't know if I can find them quickly without giving away all my email and stuff. So and talk to me. I can put it in a chat message on Discord later on, the links to TLP. Do you know if Microsoft is planning to resolve this permanently with an update? I think they are, but or at least they told me they are, but they didn't put a timeline to it. The email that I received this week was promising that they actually did fix it already in a new Windows 10 update, but I wasn't sure because the message was a little ambiguous. So I asked the account manager to ask again at development, but I didn't have a response yet. So I'm pretty sure they are going to fix it. I just don't know why and when. And let me check my email on my phone for a second. Maybe I got a new email from Microsoft. I don't think so, but let's check anyway. Then the next question from Mike: can you provide the PowerShell commands to change the settings? Yes, I can. I can put them in the chat. Let me. Panelists and attendees. And if all goes well, it should be in your chat right now. Let's see. No answer yet from Microsoft.
Yeah.
So,
no more questions.
No more questions. Yay! Another question. So when Wireshark identifies those frames as retransmissions, you would actually rather call them duplicates. Yes. So there could be a code fix that checks for either hashes or just IP ID. But then again, it's always difficult to make a proper conclusion. So yeah, I think it might be nice to have like an expert info on this. Like, okay, it looks like a retransmission, but hey, I see the same IP ID, so it might be a duplicate. So we could add that. So if you really like that, you could add it to the GitLab issue tracker and mark it as an enhancement request, and then we could maybe could add that. Yeah. All right. Yeah, so nice to see. Like, I think at the top, I saw like 170 people or something. That's amazing. That's an advantage of doing it online, that you get a much larger audience, and also a lot of people that normally wouldn't go to SharkFest and now are able to attend and maybe start loving Wireshark more than they already do. So yeah. Any more questions regarding this case? Or any other questions about TCP and troubleshooting in general? Otherwise, I think we should close the session early. And
yeah, just want to let everyone know that I'm gonna post the PowerShell commands as well in the Zoom 2 Discord channel. So if you want to look it up later, they're gonna be there.
Yeah. And I will look up the TLP links and put them in the Zoom 2 Discord channel as well. Oh yeah.
Okay,
that's a
then.
good point. Like, I would like you to take a minute to do the survey, because then we can know whether the session was actually to your enjoyment and whether we should change things, and maybe other suggestions or comments or positive or negative feedback. Please visit the survey.
Okay, so then if there are no more questions, then I would say we can close this. Thank you, Sake.
Yep, I agree. Thanks a lot for attending, and hopefully talk to you on Discord somewhere these 2 days. And yeah, have a nice SharkFest.